All right, so here we have grandparent reared children historic. So the number of children under 18 living in households headed by a grandparent can be modeled by P t equals 2.111 e to the 0.04 t million children, where t is the number of years since 1980. So that's a key to know. And so we need to write the rate of change formula for p. So we need to find p prime, basically, of t. And then we need to find out what the number of children, how rapidly it was changing in 2010. Well, 2010 is what, 30 years? So that's going to be t equals 30. Okay. All right. Well, if we look at this, that's a composed function. So if we keep, let's just, we can convert the letters and stuff. So let's call that g of x is equal to, and we'll say 0.04 x. I'm going to probably mess everything up because now I'm going to go from t's to x's and back. But I think if we call this f of x equals 2.111 e to the 0.04x, and then know that when we go back, we have to convert it back to the p and t's. That's going to make us easier because we can do exactly like we've been doing all the way. Find g of x, find f of g, and we're done. And if we did this, we'd have to find, p of t, and then we'd have to find some other letters and do stuff and change it. So then it might confuse you. But I think it's going to be less confusing if we change it to f of x and use this equation and then know that we have to convert back into something like that. Okay. So then that gives me f of g is equal to what? Well, it's going to be 2.111 e to the g. Well, then I can find g prime of x and f prime of g. Well, that's just going to be 0.04. And this is going to be, well, that's just going to be 2.111 e to the g. Okay. So df dx, and again, we had to convert it to this formula first. So when we get done, we're going to have to convert it to p's and t's, but it's not going to be hard. All right, so that's going to be equal to, well, I'm going to take 2.111 e to the g times 0.04. And so then what we're going to have to do is we're going to have to take and replace that g, and we can also multiply here. So if we take that 2.111 times 0.04, we get 0.08444. E to the g is 0.04x, and that's going to be my df dx. Now converting it back to p's and t's, then that means I have the dp dt is equal to 0.08444 e to the 0.04 t. Okay, so that's all it does. Or we can say that's basically our p prime of t. So however we want to look at it, this way or this way, but that's our value. Now, could we have left it and just changed that? Yeah, we could have said instead of this, we could have said that's 2.111 e to the 0.04 times 0.04. We could have left it like that, or we could have gone ahead and multiplied it out here. Is either one more correct? Not really, but I would say maybe this one's more simple because when you go ahead and do part B, then you just have to plug in 30 here instead of, and figure that out instead of having to take this times this times this. You only have to take this times this. So one less multiplication at the end, but it doesn't matter. Okay. So now we need to find p prime of 30. And so we're going to take the 0.084 times e to the 0.04 times 30. And that gives us 0.280. And that's going to be what, million children per year. Okay. And so that's how rapidly it's growing. It's growing by 0.28 million children per year. Okay, and that was our derivative. So this is kind of our part A. This is our part B. All right. So let's stop there, and then we'll come back with another one.